non-metal negative charge, that's an ionic compound. And when you have metal and negatively charged polyatomic ion, that's a ionic compound there. So whenever you have an ionic compound, if it's water soluble, you have to pay attention to the formula here. This 2 goes in front of this particular ion. Okay? So in this case, the chloride ion concentration is twice as much as the copper ion concentration. And we use that bracket representing the molar concentration. So that's something that we need to pay attention to. And here's an example. If you have 6.73 gram of sodium carbonate, and you dissolve it in enough water to make it 250 milliliter total volume, what is the molarity of sodium carbonate? What's the concentration for the molar concentration for sodium ion carbonate ion? Well, we have to recognize when you have sodium carbonate, one of the 16 polyatomic ions, CO3. Okay, when you dissolve that in water, you get sodium ion, you get carbonate ion, you get 2 sodium ions in there. Okay, so this 2 goes in front of the sodium ion when it's dissolved into water there. Okay, so what we need to do here is that the question is asking you what's the molar concentration, what's the molarity of the sodium carbonate solution? Well, we have 6.73 gram of sodium carbonate. Okay, and we have each mole of sodium carbonate equivalent to 105, 106, well, somewhere, I don't want to write all the numbers there, 106 gram of sodium carbonate. So if you do this calculation, this will give you the number of moles of sodium carbonate. By definition, the molarity of sodium carbonate solution, number of moles of sodium carbonate, aqueous solution in water is always a solvent. The total volume, 250 what do we need to do about 250 milliliters? We got to convert it into liters. Okay, you can't use milliliter directly because the definition is moles per liter. Now, milliliter cancels out. So the calculation involved in here really is just dimensional analysis. You just have to identify the correct conversion factor, plug them in, and do the calculation. So if you do 6.73 divided by 106 and divided by 0.25, that's 250 milliliter, you would end up with the molarity, well, you figure out the number of moles first, and then the molarity would be 0.254 moles per liter. And the question continues to ask you, what's the molar concentration for sodium? What's the molar concentration for carbonate? Well, if you look at this particular equation, each mole of sodium carbonate, when dissolved in water, will give you 2 moles of sodium ion, 1 mole of carbonate ion. So the carbonate ion concentration is the same as the concentration, molar concentration of solution, 0.254. Sodium, 2 times that, 508. Okay, so this is the type of calculation, a fairly simple type of calculation that you will see in your homework assignment in chapter 4. Okay, so this is something that we do need you to be able to figure out. Now, this is solely based on the definition. You have to know how we define molarity in order to be able to do calculations. Okay? Once you identify the conversion factor, calculation is quite easy. Another type of question that you will encounter involving molarity, if you have 0.123 capital M moles per liter sodium hydroxide, what volume of that solution will contain 25 gram of sodium hydroxide? So that's another type of question there. We give you the molarity, we give you the grams of the solute. We ask you to figure out what is the volume of the solution. Okay? Now, when you solve this type of question, along with this type of questions there, the key thing that you need to remember is that's our conversion factor. That's how we define molarity. You got to know how we define molarity in order to do this type of calculation. Okay, so in this case, the previous question there, moles per liter, we gotta figure out the moles, we gotta figure out the liters, and then we divide the two numbers, we end up with molarity. So in this particular question, we ask you, if you have a concentration of the sodium hydroxide solution of 0.123 moles per liter, how many milliliter or how many liter of solution will contain 25 gram of sodium hydroxide? Well, this number is given, 0.123. Well, the unit is moles per liter. Pay attention to the unit, always. Okay. Now, this number is the X that we're trying to figure out, the volume. And this number, well, we have 25 grams. We got to convert 25 grams into moles. Now, if you convert 25 grams into moles, and then 0.123 moles per liter equals to that many moles divided by X. X is the only unknown that we need you to find out. So in this case, we have to figure out 25 grams of sodium hydroxide is equivalent to how many moles? Well, we have the conversion factor there. So we got 25.0 grams of sodium hydroxide. Each mole is roughly about 40 grams. Okay, 39.9971. Gram cancels out. So this will give you the moles. The number of moles divided by X liter should equal to 0.123 mole per liter. So this is your N now. And everything else is given. Okay? And you figure out the number of moles of sodium hydroxide, 25 divided by 40 is 0.6250. And that number divided by X equals to 0.123. So X equals to 5.08. What it means here is that for a solution of sodium hydroxide with a concentration of 0.123 moles per liter, you got to get 5.08 liter of that solution. It's almost 2 gallons, and a little bit more than 1 gallon. 1 gallon is 3.78 liter. Okay, almost 2 gallons there. In order to have 25 grams of sodium hydroxide in it. So what we've introduced here is that we can actually quantify either the volume or the mass of the volume of the solution or the mass of the solution in a given solution, if we know the molarity. Now, if we don't know the molarity, but we know the quantity of the solute, the volume of the solution, we can calculate the concentration. Okay. So another question before we'll probably have a couple more on examples there, and we'll probably take a break and we'll come back on about 5-10 minutes break there, and we'll come back and we'll look at the concentration. Okay. Now the Scantron of your exam, you will get them back by Wednesday, the latest. I'm waiting for the exams to come back from the test center, and so I don't want to hand out the Scantron before I have everything coming back to me. So I will hold on to it, and if you want to take a look at the exam after you get your Scantron back, and you're more than welcome to come to my office and we'll sit down, we'll pull out your exam and compare your Scantron. Whatever questions you have marked incorrectly, we'll pull out the exam there and we'll review it. Okay. And once again, thank you for a great job on the first exam there, and keep it up. And I want to see similar results for the